Hi there, lesson 7.1. Today's lesson, we're going to be adding and subtracting polynomials. So we're first going to find the degrees, we're going to classify them, and then add and subtract them. So what is a monomial? And then more importantly, polynomial. So to define it, it says a monomial is a number, a variable, or a product of number and one or more variables. Basically, a monomial is our terms in an equation or expression. So when we're talking about the degree of a monomial, it's the sum of the exponents of the variables in the monomial, all right? So the degree of a non-zero constant is 0, and the constant 0 does not have a degree. We'll talk about this more as we lead into it, but these are just the definitions, and you can find this information on page 207 in your student journal. So here's an example, a monomial 10. It's just the term, it's a constant, right? The degree is 0. And I'll get more into explaining that a little bit later. So the monomial 3x, right? It's the product of a number and a variable. The exponent of the variable is 1, therefore the degree of the monomial or term is 1. When you have this, the exponent of a, so we have 1/2, right? It's kind of like the coefficient has a degree of 0, but then a has a degree of 1 and b has a degree of 2. So the total degree of this monomial is 3. Here, negative 1.8 m to the 5th power has a degree of 5. So this is not a monomial because it's the sum of two monomials, not just one. 5 by itself is a monomial. X by itself is a monomial, right? A monomial cannot have a variable in the denominator, so we wouldn't say that. A monomial cannot have a variable exponent, and it cannot have a negative exponent. Okay, so just a couple different things. So the first up is finding the degree of each monomial. So remember, in A, the exponent has, or the variable x has an exponent of 2, therefore the degree is equal to 2, okay? The exponent for B, x is 1 and y is 3. So when you add 1 plus 3 together, you get a degree of 4. For C, you have 3 and 3. So you have a degree for this term or monomial as 6. Notice that I'm using the word term and monomial interchangeably. That's kind of how I want you to see it. For D, this negative 3, can be rewritten. So here's the reason why these numbers have 0 as the degree. It's because we can assume that the exponent is equal to 0 because we don't see the variable. Okay, does that make sense? So yeah, so it has like a implied exponent of 0, and remember, anything raised to the 0 power is equal to 1, so it's like negative 3 times 1. But that's why the exponent of the imaginary variable is 0. I don't know if you can even say that. That's okay. Here we go. So we are going to start the extra practice is on page 207. We're going to find the degree of the monomial. So again, looking at the variable, what is the exponent? 1. Therefore, the degree of this monomial or this term is 1. W, it's a variable with an exponent of 1. 8, is there a variable? No, there is no variable. Therefore, it's assumed to have an exponent of 0. So all constants, all integers, any kind of form of numerical terms or monomials have a degree of 0. So for number 4, A is 1, B is 1, C is 1, the degree is 3. You add all of them together, okay? For 5, 2 plus 1 is 3. I want you to do number 6. Pause the video and do that real quick, and then check your work. Hopefully you said that it is 2 plus 3 plus 1, or 6. For number 7, 1 plus 3 4, and number 8, 0. I like to cross my zeros even though I didn't cross that one. Okay, here we go. Moving right along. The core concept. Well, we're classifying polynomials. We're talking about polynomials. So what is a polynomial? It's a monomial or a sum of monomials. Each monomial is called a term in the polynomial. So remember, I've kind of already talked about them being terms. Look at this binomial, 5x plus 2. It's like an expression. Here's a trinomial. So binomial means 2 terms. Trinomial means 3 terms. Pretty much anything over that is just simply polynomial. We don't have special names for 4 terms, 5 terms, 6 terms, and whatever. The degree of the polynomial is the greatest degree of its terms. So instead of, so now you're being having terms or monomials separated by addition, subtraction, things like that. We're not going to be adding the exponents together. We are simply going to look at the degree that has the highest power, and that would be the degree. So this would be a 3rd degree polynomial, right? If I had to classify it. So a polynomial in one variable is in standard form when the exponents decrease from left to right. So one of the things I like to say is it's in descending order of the variable, descending order of the power of the variable. So we start with the cubed, then the squared to the first power, and then obviously, an exponent of 0 right here. So the degree goes down when it's in one variable. Then if there's multiple different variables, a lot of times you'll see mathematicians, it seems to follow a rule of alphabetical order. All right. So when you write a polynomial in standard form, the coefficient of the first term is called the leading coefficient. So here's some things that you might need. I believe this is on page 207. Yeah, it is. So as you're doing some of the next examples, you can always look back to this. So first, you'll rearrange the terms to put them in descending order of the variable so that the exponents decrease by 1, right? Left to right. Then you look at the leading coefficient, which is 2. The degree here of this whole polynomial is 3. And then, and this is the constant term. And if we had to classify it, we just call it a polynomial. All right, so let's keep going. So writing this in standard form, identifying the degree, leading coefficient. So the first term, 15x, has a degree of 1. X cubed, negative x cubed, has a degree of 3. 3 has a degree of 0. So we're going to put them in descending order of the variable, meaning we'll take this x cubed and put it first, but notice that it is, oops. Notice, I gotta get a little mark there. Notice that it is like a negative x cubed. So when we rearrange the term, keep the operation in front of the number because that is actually the sign of the number. So we have negative x cubed plus the 15x plus the 3. The greatest degree is 3, so the degree of the polynomial is 3. The leading coefficient is a -1. And to classify it, because there's 1, 2, 3 terms, we would call that a trinomial. Okay. So that's what we're going to do, classifying them. So for A, right, to put it in standard form, well, it's already written in standard form. It's a monomial. There's no other terms to rearrange or put in descending order. The degree is 4. The type is monomial. Here, we can rearrange them, right? This one would move to the first position, this negative x would be second, and then the constant would be last. So 5x squared minus x plus 4 is a second degree trinomial. And we're going to be working with these quite a lot throughout this chapter and next chapter and pretty much a couple chapters to go. All right, here, put them in descending order of the variable. Q to the 5th first plus 8q is 5th degree binomial because there's 2 of them. All right, so in working on this problem, it says in exercise 9 through 12, write the polynomial in standard form, identify the degree, leading coefficient of the polynomial, then classify it. So I kind of go through and I like to underline them. So I look at the one with the high. So this is an exponent of 1, exponent of 2, and then I assume 0. So this would be my first term, this would be my second term, and this would be my third term. So I would have 3x squared, and it's positive, so that's positive, plus x and plus 5. Descending order of the variable. My degree is going to be equal to the highest degree term, which is 2, so a degree of 2. The leading coefficient, I'm going to abbreviate those, is 3. And then I'm going to classify them. There's 1, 2, 3 terms, so we would call this a trinomial. Okay, switch colors. Over here, there's one term. It's a monomial. So I would just simply say that this is standard form. Okay, my degree is equal to 1. The leading coefficient is the coefficient of y, or the square root of 5. And then because there's only one term, this is the monomial. Okay. Number 11. So I'm looking at this and there's two terms. One has an exponent of 5, one has an exponent of 8. So the 8 is the highest degree of x. So that would be my first term and my second term. So I have 6x to the 8th plus 3x to the 5th. So when I'm talking about my degree, the degree would be the 8. When I'm talking about the leading coefficient, that would be the 6. And when I have to classify it, it would be a binomial. All right. I would like you to pause the video and do number 12. And so if I have three terms here, 4 has the highest exponent, so that would be the first one when I put it in standard form. Then it goes down to 2, and then, oops, that would get 2, and then 3. So I would have f to the 4th plus f squared minus the 2f. Okay, so the degree would be 4, leading coefficient would be 1, and the last thing is to classify it. Okay. All right. Now we're going to be adding them. So to add polynomials, you want to add like terms. You can use vertical, horizontal method. Oof, I will not be showing you the vertical. I'm actually going to be showing you this, but not with as many steps. So stay tuned. Let's just go right out of this. All right. So when we're doing this, all right, notice that this is adding. And so it's kind of like we're distributing a positive 1. It's kind of silly, but we can almost let go of all these parentheses. I guess they were writing them to let you know that that's what they are. So I would look at this as negative 4x plus 9 plus 6x minus 14. Now, underline like terms, right? Or you can circle them. Remember, we used to circle them with the sign in front of it? All right, now we want to put these in standard form. So in this case, the variable would go first. So we have the negative 4x plus 6x. So we have a positive 2x. Then we have a negative 14 and a 9. So we'll have a negative 5. And that's in standard form. So make sure you're putting them in standard form. Okay? All right. Moving right along. Why don't you try number 14? What is the simplified form for number 14? For 15, okay, if I look at this, I have squared, exponent of 1, exponent of 0, squared, 1, 0. So these first two terms become the leading term, all right? Then the next one, and finally the constant. So these were in order, makes it pretty easy. So 1 plus negative 1 is 0. So the x squared term disappeared. 3x plus 6x is 9x, and 5 minus 4 is a positive 1. And 9x plus 1 becomes the simplified term. All right. So I have squared, cubed, and 0. So the cubed is my first one. So I kind of am working with the standard form and the like terms all at the same time. So I'm underlining, instead of just underlining the first term and finding the like term, I'm first evaluating the highest degree because I know that that has to go first. So my t cubed goes first. Then t squared would be my second term. Oh, here's a t squared as well. There is no t, but there is a t here that will go third. And then finally, the constant, and I underline it 4 times. So now take the ones that are underlined 1 time. This is just a method of keeping it straight. So 3t squared minus 2t squared just gives me, oops, it's cubed, not squared, silly Kleinman. All right, so this is 3t cubed, oh my goodness, and negative 2t cubed. All right, then we'll go to the squared. We have 1 plus 2, so we'll have 3t squared. Whew. Then we have this t, right? That's our third one. So descending order of the variable, and there was nothing to add to it, so it's okay. And then minus 3. So t cubed plus 3t squared plus 7t minus 3. All right. Now, to subtract a polynomial, we want to add its opposite. To find the opposite of a polynomial, multiply each of its terms by -1. So this is a little different. So since this is subtraction, it's like we're distributing a -1. So we do have to take that step to rewrite this. And I won't, again, I'm not going to line these up like this. I don't like doing it. I just don't. All right. You can look in your textbook or so I'm just going to rewrite these. So the first one becomes g minus 4, and then -1 times 3 is -3g. -1 times -6 is +6. So notice how what's inside the parentheses when it is after subtraction is the opposite of what it was. It was positive g, now it's negative. Positive 3g, now it's negative 3g. Was -6, now it's +6. So now, first term, right, was the variable with an exponent of 1, and then the constant. So 1 plus -3 is going to be -2g. -4 plus 6 is +2. Okay. Change colors here. I'll let you do number 18, and I'll go down to number 19. So I'm going to rewrite. So the opposite of a -3 is a positive 3x squared. Positive x and positive 8. I changed the sign because they all precede the negative. Now, the exponent of 2 becomes my first term. The exponent of 1 is my second, and the constant is my third. Okay, so here, 3 minus 1 is 2x squared. Then I do my x, which has nothing to combine or add, and then the -5 and the positive 8 is a positive 3. Okay. And finally, this one, let's rewrite it. So k squared plus 6k cubed minus 4 minus the 5k cubed. So what I'm doing, it's kind of like distributing a -1, okay? -7k and a positive 3k. This is a really important step when it's preceding the subtraction. Okay, so here's degree of 2, degree of 3, degree of 0, degree of 1. So I want to start with 3. It's going to be my first term. And then 2 will be my second term. Then degree of 1, this k, will be my third term. And finally, 2, 3, 4 will be my fourth term. So I can take my first 2, 6 minus 5, and get k cubed. Then my second terms, 3 and 1, become 4k squared. It's just a lot of keeping track is really what it boils down to. And notice how I'm also putting it into standard form by descending order of the variable. So I'm going 3, then 2, then 1, so -7k, and there's nothing to like term or add combine with it. And then finally, the constant, again, nothing to add with it. So this has been adding polynomials and your introduction to polynomials. So be sure to come to class with any questions that you may have.